Bismillahirrahmanirrahim. Assalamu alaikum, students. Hope you all are very fine and taking good care of yourself. As you know that we have started our chapter number 11, that is about organic chemistry. And in the previous lesson, you have studied in detail that what are organic compounds, what is organic chemistry, and how the different organic compounds are represented in different chemical formulas. And you have studied in detail the different formulas of organic compound, what are their chemical formula. Now our next topic is classification of organic compound. Dear students, we have up till now 10 million organic compounds, and it is very difficult for us to deal with huge number of organic compound and to study their properties. So we want to classify all those elements into single classes that have same characteristics. So the compounds that have same chemical properties, they will be placed in the same classes, and it will be easy for us to study their properties. For example, if we classify the students of different IQ levels, like mediocres and the extra level of IQ, and these and we categorize them into different classes, so it will be easy for us to understand that the student belonging to this class are of this IQ level, and student belonging to this class are of this IQ level. Similarly, but remember one thing, student, hard work can beat the extra IQ level as well. No, don't think that you don't have an extra caliber or extra IQ level, so you can't do anything. Always hard work can beat the IQ level as well. Remember this thing. This is the one of the blessing of Allah, that some people are blessed with extraordinary intelligence, but hard work is never denied. Okay. Now classification of organic compound is like we want to study the different we want to place the different organic compounds into a single class that are of same chemical properties. So here is the classification of organic compounds, that how we are going to classify the non organic compound. Mainly there are two classes of organic compound, and whenever we are going to categorize things, we take one standard upon which we are going to categorize them. As you for example, as I have given you the example, that if you people are going to categorize on the basis of IQ level, then we have selected a one standard entity, that is IQ level. So here what is the standard we have set for the classification of the organic compound is the carbon skeleton. We know that we have studied in detail in our previous lesson that the organic compounds are those in which carbon and hydrogen. So it is compulsory, it is understood that organic compound will always have carbon and hydrogen as the main constituent. But now how these carbon and hydrogen are going to link with each other, what will be the link, how they are going to link with each other, how is their linkage. So that is their carbon skeleton. Either the skeleton, all the carbon are going to arrange in a straight line, or they are going to arrange in a ring form, or they are making a branch, whatever their arrangement is. So on that arrangement, we have categorized the organic compounds into two classes, that is open chain, and open chain organic compounds are also called as acyclic or aliphatic compound, and second one are those closed chain or cyclic compound. Now we will study in detail that what are open chain compounds, what type of structure they have. Organic compounds in which n carbon atoms are not joined with each other and form long chains of carbon atom called open chain compounds. You can see in this structure that our carbon atoms are arranged in a single line, in a straight line, in a linear way. So this type of structure, this type of class of organic compound is called open chain compound. So these open chain are also called acyclic, mean there is no cycle formation, there is no ring formation, or aliphatic, mean they are arranged in a straight chain. So you can see that this carbon atom and this carbon, these are the end carbon atom that are also called terminal carbon atom. These two end carbon atoms are not directly attached with each other, they are free, they are not linked with each other, and when they are not joined or linked with each other, they form long chains. You can remove hydrogen from here, again attach one more carbon, and the chain will increasing, and we will get the long chains of carbon atom, and the compounds we get will be called as open chain compound. Now these open chain compounds can be further classified into two classes, that this chain may be straight or this chain may be branch. Now what are straight chain compound? Compound in which carbon atom link with each other through a single, double or triple bond forming straight chain, for example NBT. All the carbon at you know that carbon can make maximum 4 bond, and for the 4 bond formation it can make single bond, double bond or triple bond with other carbon atom, and this bonding will be in a straight way, in a straight linear way. There will be no branching, there will be no ring formation. So such type of structure is called straight chain, and these compounds are called straight chain compound, and its example is N-butane. When the chain is straight, butane, you know that butane is for the 4-member carbon molecule, a molecule in which 4 carbon are present, that will be called as butane. Now the arrangement of carbon is shown by N. This N represent that all these 4 carbon atoms are linked with each other in a straight chain, so its name is N-butane. Second one type, organic compound in which there is branch along straight chain. These 4 carbon atom, 3 carbon atoms are attached in a linear way in a straight chain, and one of them is going to make a branch that is not going to attach over here or on this side, that is going to make a branch. So such type of organic compound in which there is a branch along the straight chain. With the straight chain you have a branch, these compounds are called branch chain compound. And this one is also butane because it is also a 4 member carbon atom molecule, 1, 2, 3 and 4 carbon atoms. So it is understood that if 4 carbon atoms are present in a molecule, that is butane. But how its arrangement will be represented, as these are going to make a branch in this structure, so it is called isobutane. For the branching we will use the word iso. In the naming we will use word iso, and for the straight chain we will use N. So this N and iso is for their arrangement. And remember one thing, if they are going to arrange in a different pattern, they have different property from each other. This N-butane have different properties from isobutane, although both of these have 4 carbon atoms with them, but their properties will be different from each other. That's why there is huge number of organic compound, because their 4 bonds of carbon have to make 4 bond. So it have so many choices for formation of 4 bond, that either it is going to attach with other carbon atom in a linear pattern, in a branch pattern, in a ring form. In this way it is going to make millions of organic compounds. Single carbon is capable of forming million of organic compound due to this property. Okay, second one, we have studied that organic compounds are divided into 2 categories, open chain and closed chain. We have studied that what are open chain compound, what are their structures. Second one is closed chain, as it is obvious from its name that the chain will be closed. Now how chain will be closed? When the end carbon atoms are not free and they get joined with each other, then they form rings and cycles. So these type of compounds are called closed chain or cyclic compound. So cyclic compounds are those in which the carbon atoms at the end of the chain are not free, they link to form ring. They are further of 2 types, homocyclic or carbocyclic compound or heterocyclic compound. Okay, first one, homocyclic. Homo mean same and cyclic mean cycle. So homocyclic means cycle stands for ring. If the end carbon are not going to free, they are going to make rings, and these rings are of same kind of atom. There will be not a different atom present in them. So such type of compounds are called homocyclic compound. What are homocyclic compound? Homocyclic compounds contain rings which are made up of only one kind of atoms, that is carbon atom, and they are further divided into two classes: aromatic compounds and alicyclic compounds. Okay, first of all, example of homocyclic compound, you can see this structure in which, look at this structure in which 6 carbon are there: 1, 2, 3, 4, 5, 6. You know that if 6 carbon atoms are present in a structure, that the name of that compound is hexane. Now, what type of arrangement this hexane endure? Either it is going to be a straight chain or a branch chain, or it is a ring, or ring of same kind of atom, or ring of different kind of atom. So in this structure you can see that this is not a straight chain. A terminal carbon atom, this one and this one, are directly linked with each other, and when they get attached with each other, they form bond, then they will convert it into a ring type of structure. You can see that in this structure only carbon and hydrogen are present, not any other atom is present in its structure. So such type of structure, such type of molecules are called homocyclic. That cycle or ring is composed of same kind of atom, that is carbon atom. So what are homocyclic compound? That contain rings which are made up of only one kind of atoms, that is carbon atom, and they are further divided into two classes, that is aromatic compound or alicyclic compound. These same kind of ring are further of two types. What are their types? Aromatic compounds, these are also called benzenide compound. Organic compounds contain at least one benzene ring in their molecules are called aromatic. What is the formula of molecular formula of benzene is C6H6, and here in this structure you can see that this is the formula of benzene. All of these three are the formulas of benzene. It can be represented in three different ways. Now, what is a benzene ring? A benzene ring is made up of 6 carbon atom with 3 alternating double bond. In this structure, you can see that 6 carbon atoms are present, and at alternate position there is double bond present. So such type of structure is called a benzene ring. And in any molecule in which at least one benzene is present, that compounds will be termed as aromatic compound or benzenide compound. Aromatic is their old name because in the old time it was considered that there is a particular aroma coming from these compound. So due to this particular aroma, these were termed as aromatic compound because of aroma or smell they endure. But now these are termed as benzenide compound as they have benzene present in them, and actually due to this benzene they have a particular aroma coming from them, and these are called benzenide compound or aromatic compound. This is the structure of benzene. This is pure benzene and it is represented in three different ways. And in this structure, this is the structure of naphthalene. In this molecule, 2 benzene rings are present. 2 benzene rings get fused with each other, attached with each other, and these 2 benzene ring, when they get fused with each other, they form the molecule that is called naphthalene. So this naphthalene is also an aromatic compound as it contains benzene ring in its structure. So these are homocyclic compound because in their cycle only benzene ring is present. Either 2 benzene ring, 3, 4 benzene ring are getting fused with each other. So these are type of homocyclic in which carbon and hydrogen is there, and what molecule is going to repeating in these huge molecules, macromolecule, that is benzene. Second one, alicyclic or non-benzenide. So it means that there is no benzene ring in their molecule, but these are homocyclic as their cycle consists of same type of atom, that is carbon and hydrogen. So carbocyclic compounds which do not have benzene ring in their molecule are called alicyclic or non-benzenide compound. For example, cyclobutane. Okay, In the previous classes, you have studied the structure of butane, N-butane and isobutane. Now, terminal carbon are not free. They get joined with each other and there is cycle formation, there is ring formation. And now you can count that 1, 2, 3, 4, again 4 carbon are there and 4 carbon member molecule is of butane. And as this butane is going to form a cycle, so it is termed as cyclobutane, and this one is cyclohexane. So both of these are the example of homocyclic compound because the cycle is composed of same type of atoms, that is carbon atoms. Okay, last one class, that is heterocyclic compound. Cyclic compound having at least one or more atoms other than carbon atom there in their ring. Now in these compound, hetero mean different. So in these compound, along with carbon and hydrogen, some other heteroatom will also be present. So these will be termed as heterocyclic compound, and its example are pyridine. This one is the structure of pyridine, and this one is of thiophene. In this, student, you have to remember that when we draw the structure in this way, every corner represent at every corner carbon atom is present, and you have to satisfy its tetravalency. At this corner there is carbon, and this position there is carbon, and there is a heteroatom, that is nitrogen. So this structure will be termed as pyridine. Similarly, in this structure, at every corner carbon atom is present, and at this corner there is sulfur. So this is the structure of thiophene. So these are the heterocyclic compound. Cycle consists of heteroatom, different atom than that of carbon and hydrogen. Carbon and hydrogen will be definitely present in it because it is an organic compound. But along with carbon and hydrogen, there will be a heteroatom. So that's why these are termed as heterocyclic compound. So that is all about the classification of organic compound. That organic compounds are mainly classified into open chain or acyclic compound or aliphatic compound, or closed chain compounds are those in which there is n carbon atom are joined with each other and they form ring. And now the ring may be homocyclic, or that may be heterocyclic. Homocyclic ring that composed of same type of atom. Heterocyclic contain at least one a different atom than that of carbon atom. Its examples are pyridine and thiophene. Homocyclic may be alicyclic or aromatic. Alicyclic, there is in there which there is no benzene ring, and in aromatic there is benzene ring in the molecule. So that was all about the classification of organic compound. Do practice all these structure in your rough notebooks and try to classify all the organic compound in this pattern on your rough notebooks. That's all about the classification of organic compounds. Thank you and Allah Hafiz.